Throughout the Earth's history, there have been flux periods of heating and cooling, which have led to various different mass extinctions. These events include climate change due to increased volcanism, dramatically adding large amounts of sulfuric acid in the atmosphere, as well as CO2, methane release from the sea floor, sea level change, increasing aridity, and hypoxia. The largest mass extinction event happened in Earth's history at the Permian-Triassic boundary. Almost 95% of all oceanic species and about 75% of all terrestrial species died off. Due to the enormous range of species and environments that were impacted, it is not likely that a single event was the cause, but rather a series of catastrophic and gradual events over the entire time period, collectively contributing to its demise. The Earth has undergone dramatic changes in climate over the course of its history, as it will for millions of years to come. Therefore, it is sensible to draw connections between the Permian and the climate change experienced in our modern society. Unlike during the Permian, volcanism is not as abundant in our modern world. As seen in this clip, the orange areas are where temperatures are increasing over the past century alone. The potential outlook for Earth based on its current trends of climate change is very similar to the Permian. Greenhouse gases are entering the atmosphere and gradually warming the climate to higher levels that could lead to catastrophe. Plants, animals, insects, and bacteria will all be affected by climate change if these levels of greenhouse gases get too high and reach a tipping point over which many organisms' populations will plunge. A tipping point occurs when a system has reached maximum capacity conditions beyond the point of no return. Tipping points are not just a thing of the future, they can be seen happening now. Plant growth was increasing in conjunction with the rising global temperatures, but over the past decade, there has been a decrease in plant productivity. This suggests a tipping point was reached, with plant growth causing it now to be in decline. Another tipping point example with catastrophic results is the CO2 explosions from the depths of Lake Nyos in Cameroon. Lake Nyos is a tropical body of water that has no turnover in the spring. Therefore, Lake Nyos can only hold so much CO2 before reaching its tipping point and causing an explosion. As a result of the eruption, suffocating levels of CO2 were released and caused havoc on the Lake Nyos community. A current positive feedback system that may lead to global warming tipping point is the methane stored in the ice caps and permafrost in the Arctic. As temperatures rise and ice caps melt, methane has been stored in the ground and is slowly being released into the atmosphere. Methane is 22 to 25 times more potent on mass basis as a greenhouse gas than CO2. This means that the more methane released, there will be a greater increase in temperature, leading to even more methane emissions. It is a positive feedback system, pushing the world toward its temperature capacity tipping point. Climate change can be a major cause for extinction, which was evident during the Permian and may be a possible outcome of the current Anthropocene. At the start of the Industrial Revolution, the atmospheric CO2 levels were just at 275 parts per million. Current trend shows that the atmospheric CO2 is at 388 parts per million, past the tipping point of 350 parts per million. The question now is if we can get below 350 parts per million before it's too late.